Hello children, today's our topic is inverse trigonometric functions. Before introducing inverse trigonometric function, have a look on trigonometric function. Basically there are six trigonometric functions: sin x, cos x, tan x, cot x, sec x and cosec x. You have studied all these six trigonometric functions, their domains, codomain, range and graphs in class 11th. So I think you are aware of these trigonometric functions. Now as our topic is inverse trigonometric function, children have a look on this example. Sin x is equal to 1 upon 2. If we solve it for 0 to 2 pi, we get x is equal to pi by 6 and 5 by 6, 5 pi by 6. Children, as our topic is inverse trigonometric function, for a function to be invertible, we must have a 1 and onto function. It seems from sin x is equal to 1 by 2 that it is not 1 because 1 by 2 has two pre-images, that is pi by 6 and 5 pi by 6. It means here sin x is not invertible function. It means sin inverse x does not exist, but our topic is inverse trigonometric function. So can it be possible? Naturally sin x is not an inverse function, but we can make it by restricting its domain and range. Now let us consider a function. I am just zooming on that. Sin x such that minus pi by 2 is to minus 1 to 1 closed interval. Both are closed intervals. So if we have to study inverse trigonometric function, that so we have to restrict its domain and range as well. Children, don't be confused between these two. Sin inverse x is not equal to 1 upon sin x, and sin inverse x is also not equal to x upon sin. Here inverse doesn't mean reciprocal of that, so mind it. Now children, there are function after restricting their domains and their ranges. We found 6 inverse trigonometric functions that are sin inverse x with domain minus 1 to 1, and it's a range. This range is also called principal value branch. Cos inverse x minus 1 to 1, and its range is 0 to pi. And similarly we can see that cosec inverse x, sec inverse x, tan inverse x, cot inverse x, and so on. So learn please all these 6 inverse trigonometric function, their domains and their principal value branch. Now a question arises whether we have this restriction fixed or we can take other restriction to show that sin x is 1 2. Children, there are other intervals exist, but this interval is called principal value branch. Okay, So this will be called principal value branch. Other may exist from principal value branch. Now children, I want to show you graph of sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. First graph is sine inverse x. As you can see that, if you recall that graph of sine x was formed on x-axis, whereas this graph is formed on y-axis. So this is the difference between graph of sine inverse x and sine x, and same happens with other graphs too. Cos inverse x, you can see cosec inverse x, you can see sec inverse x. You can see these graphs by pausing this video. So I am not going to waste much time on this. Now see other graphs. There are tan inverse x and cot inverse x. Now take an example. Here question which will be asked in your exam will be to find principal value branch of given particular function. Now question number first, find principal value of tan inverse minus 1 upon 3. Children, solution is as follows. Put tan inverse minus 1 upon root 3 is equal to y. This implies tan y is equal to minus 1 upon root 3. This implies minus tan pi by 6. This implies tan of minus pi by 6. Children, minus pi by 6 belongs to minus pi by 2 to pi by 2, which is principal value branch of tan inverse x. So principal value will be minus pi by 6. Now take another example. Find principal value of cot inverse minus root 3. We have solved it like example 1. Similarly, we found that cot y is equal to cot 5 pi by 6, and 5 pi by 6 belongs to 0 to pi, which is principal value branch of cot inverse x. Now children, our next example is, what is the value of sine pi by 6 minus sine inverse minus root 3 by 2. Children, we shall first find principal value of sine inverse minus root 3 by 2, as you are told in examples first and second. So here we found principal value of sine inverse minus root 3 by 2 is minus pi by 3. Now put this value to given question. You will get sine pi by 6 plus pi by 3, that is equal to sine 2 pi by 6. Further it gives sine pi by 2, which is equal to 1. Now children, I want to tell you certain properties of trigonometric function. These properties will be helpful while you solve other problems. So have a look on these properties. Please note these properties on your notebooks and learn them properly. Property 1 is sine inverse x. Sin x is equal to x, where x belongs to principal value branch. Similarly, cos inverse x is cos x is equal to x, and there are 6 properties in property 1. Now in property 2, sin inverse 1 upon x is equal to cos sec inverse x. Cos inverse x is equal to sec inverse x. Now here have a look on tan inverse 1 upon x. It will be cot inverse x if x is greater than 0. If x is less than 0, then we shall have pi plus cot inverse x. Now move to property 3. Property 3 is sin inverse of minus x is equal to minus sin inverse x, and this is same up to cosec inverse x. For cos inverse x, cos inverse of minus x is equal to pi minus cos inverse x, and for sec inverse minus x is equal to pi minus sec inverse x, and for cot it is the same as for cos. Now property is 4. Sin inverse x plus cos inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Sec inverse x plus cosec inverse x is equal to pi by 2. Now property 5. Tan inverse x minus tan inverse y is equal to tan inverse x plus y upon 1 minus xy when xy is less than 1, otherwise will be secant. And similarly we have written tan inverse x minus tan inverse y. Children, these properties are not complete. We shall cover remaining properties in our next video. So thank you for watching this video. You found useful, then please like and share this video. Thank you very much.